Welcome to Cosmic Compass, where we navigate the mysteries of space and time, one story at a time. Today, let's journey to the edge of Saturn's atmosphere, where a spacecraft, after 2 decades of exploration, is about to make its final dive. Cassini has revealed astonishing truths about the ringed planet and its many moons, but now it faces a noble end, diving into the very world it helped us understand. What did it see in its final days, and what legacy does it leave behind? Let's find out. In just a few days from the making of this video, something remarkable will happen. A spacecraft that has served humanity for nearly 2 decades will end its mission, not with silence, but in a blaze of data. NASA's Cassini orbiter, the only spacecraft to orbit Saturn, will dive intentionally into the gas giant's atmosphere. This isn't a malfunction or an accident. It's a carefully planned, poetic conclusion to one of the most ambitious space missions in human history. As Cassini descends into Saturn's thick atmosphere, its antenna will remain locked on Earth, transmitting real-time data about the composition of the planet's upper layers, until, of course, the drag becomes too great. The thrusters can no longer keep it steady, and the spacecraft is pulled into the depths of a world it spent years exploring. Cassini's final dive marks the end of a mission that began back in 1997. Over the course of 20 years, the spacecraft travelled billions of kilometres, orbited Saturn more than 200 times, and fundamentally transformed our understanding of this distant giant and its moons. And now, in this last stage of its life dubbed the grand finale, Cassini has been flying tighter orbits than ever before. It has passed between the planet and its rings, threading the needle with astonishing precision. These close passes have provided unprecedented views and measurements. For the mission team, this moment is bittersweet. Cassini has outlived expectations, withstood the harshest conditions, and sent back a treasure trove of data. And though it's nearing its final moments, its legacy will endure in the discoveries it has made and those yet to come, hidden in the vast archive of data still being studied. Let's now turn our attention to one of Cassini's most fascinating subjects, the so-called shepherd moons of Saturn, tiny, often overlooked moons that play an outsized role in shaping the planet's iconic rings. Cassini's grand finale allowed it to observe these moons in far more detail than ever before. Take Atlas, for instance, a small 40-kilometre wide moon orbiting near the edge of Saturn's A-ring. From Cassini's images, it appears oddly smooth, with a bulging equator that gives it the shape of a flying saucer. Why? Because dust from the rings constantly settles onto its surface, especially around the middle, creating a sort of dust pancake in space. Next is Pan, slightly smaller at 30 kilometres across, residing in a gap known as the Encke Gap. It too collects ring particles, sweeping its orbital path clean. In doing so, Pan maintains the gap's structure, acting as a cosmic janitor. Then there's Daphnis, only 8 kilometres in diameter, located within the even narrower Keeler Gap. It's tiny, but its gravitational influence creates striking ripple effects on the edges of the surrounding rings waves that extend for hundreds of kilometres, both horizontally and vertically. Can you imagine sitting on that moon, watching Saturn's rings ripple like water in a pond as your tiny world carves a path through cosmic dust? But it wasn't just the moons that caught Cassini's eye. The rings themselves revealed phenomena that are as beautiful as they are complex. One image in particular captured what's known as a spiral density wave in the B ring, a structure caused by gravitational resonance with Saturn's moon Janus. At first glance, the image seems to show dozens of concentric rings, but in reality, it's the same few spiral arms looping around the planet, again and again, each tightly wound. What's truly mind-blowing is how this pattern encodes history. Every few years, Janus switches orbital positions with its twin moon Epimetheus. each time that happens, the rings respond by creating a new crest in the wave. NASA scientists say that the distance between each wave crest corresponds to 4 years of orbital shifts, meaning the rings literally store a timeline of motion stretching back decades. You might compare it to tree rings recording age and climate over time, but here it's gravity writing on a canvas of ice and dust, encoding the story of Saturn's moons in silence. Cassini also observed propeller features, miniature disturbances in the rings caused by tiny moonlets, some less than 2 kilometers wide. These moonlets can't be seen directly, but they leave behind trails dragging ring particles with them like snowballs leaving tracks through a frozen lake. And then there's the mysterious solid clumps in the F ring, thought to be born from collisions and gravitational nudges by nearby moons. They survive repeated impacts, scattering dust and creating hazy clouds that sometimes orbit with them. What lies inside these clumps? No one knows for sure, but the evidence suggests they're solid, persistent, and possibly very old. Of course, no mission to Saturn would be complete without looking directly at the planet itself. During the grand finale, Saturn's northern hemisphere was in full summer, offering Cassini a clear view of one of its most iconic features, the hexagonal polar vortex. At the heart of this giant hexagon is a massive hurricane-like vortex with an eye wall many times larger than anything on Earth. And fascinatingly, this region changes colour, with the season's images from 2012 show a darker hue, while more recent captures reveal a shift to golden tones. Using different wavelengths of light, Cassini also revealed other storms scattered across the planet's bands, features reminiscent of Jupiter, though softer and more diffuse in appearance. And then there's the horizon, something rarely captured so clearly from such proximity. In some images, you can see a thin stratospheric haze hugging the curvature of Saturn, gradually fading into the deeper atmosphere. Let's pause for a moment. When Cassini plunges into that atmosphere, it won't survive to reach this haze. The heat and pressure will destroy it long before, but in those last seconds, it will transmit data no spacecraft has ever gathered, first-hand measurements of Saturn's upper atmosphere. That final signal will mark the end of Cassini's voice, and so the spacecraft that once flew past Venus, Earth, and Jupiter, that braved radiation belts, icy rings, and gravitational slingshots, will meet its end not with silence but with revelation. It's a kind of spacefaring hero's death, a controlled sacrifice made to protect the possibility of life. You see some of Saturn's moons, like Enceladus and Titan, may harbour subsurface oceans. Crashing Cassini into Saturn ensures it will never accidentally contaminate those potentially life-bearing environments. There's something noble in that decision, a final act of responsibility by a machine that has given humanity so much. To the mission team, scientists, engineers, communicators, we owe immense gratitude. Thanks to their work, we've not only seen new worlds, but understood them. As we say goodbye to Cassini, we don't just close the chapter on one mission. We turn a page in our understanding of the solar system. Its data will continue to yield insights for years, perhaps decades, and its spirit will live on in future explorers, robotic or human, who will one day return to Saturn and go even further. If you'd like to dive deeper into Cassini's discoveries or explore the strange beauty of Saturn's moons, check out the playlist linked here on Cosmic Compass. And if you're new here, welcome. We hope you'll join us as we continue our journey across space and time. Until next time, look up, stay curious, and keep exploring. Cassini's journey may be over, but the story of Saturn and of our place in the universe continues. If this mission has inspired you, as it has inspired us, we invite you to explore more with us here on Cosmic Compass. You can check out our playlist on Saturn, its moons, and other deep space missions. And if you're new here, consider subscribing so you don't miss where we're headed next. Until then, stay curious, keep wondering, and we'll see you in the stars.